Okay guys, Professor Doney here. Hopefully this will be the last installment for the trig intro and get us finished up here. I'm just putting our right triangle back up. There's our hypotenuse, which is always opposite to 90. We refer to it as the adjacent side. Whoa, sorry about that, because it's adjacent to the angle. And this is the side opposite because it's opposite the angle that we picked as theta. Alright, so we rearrange our two equations. We're not going to worry about tangent right now. As the adjacent side, we can find out how long this is if we know how long this is and we know the angle. Hypotenuse, cosine of that. So how are we going to use the two-dimensional motion? Well, two-dimensional motion means we are usually launching something at some angle. Let's call that angle 30 degrees. That's more like a 45, but you get it. And let's say we're going to drive off at 10 meters per second, about 22 miles an hour. The solution in most physics books are going to tell us, look, we need to deal with this angle because we have equations to deal with things in the x direction. And we have equations, if you remember from back, that deal with the y direction. Now I'm just going to write them here in the x direction. Okay. There's a half at squared, right? And we also have ones for the y direction, so we change the a's to g's, we change the x's to y's. But those are the equations we know how to use for motion. We're going to continue to use those for two-dimensional motion, but we have to deal with that angle. Okay? Just get a little different color here. Please let me know what you think about these colors, which one's the best. I'll try to stick with those. So we launch an angle at launch an object at 10 meters per second at an angle of 30 degrees. It's the same thing as if I had a 30-degree ramp and I take my bike or my car and I drive off of it. You know, if you're Pastrana or somebody like that, we make a ramp, or you're on your bike and want to get on YouTube and be famous, make a ramp, you go off at a certain speed. That's really representing it that way. There's our speed. We make that our initial velocity off the ramp. Now, since these equations are in the x direction, we also have versions in the y, we have to break this up because this is neither in the x or in the y. It's somewhere in between, right? That 30 degrees isn't x and it's not y, it's 30. We need to move this into x and y. So we need to know, if I'm going off the ramp at 10 meters per second, what does that mean for me going horizontally, and what does it mean for me going vertically? How fast am I going horizontal? How fast am I going vertical? All right? So to find the horizontal, I want to know the adjacent side of that triangle. I treat this side of the triangle as 10. I treat that angle as 30 degrees, and I want to find the adjacent side. So the adjacent side is really telling me how fast I'm going initially in the horizontal or x direction. That's going to equal the hypotenuse, cosine of 30 degrees. Again, that should give us 866 that way. In the y direction, we want to know this side of the triangle. How fast am I going up if it's 30 degrees going at 10? The opposite side tells us the initial velocity in the up or y direction. That's going to be 10 sine of 30 degrees. And again, if we set our calculators to degrees and not radians, that should be 5 meters per second up. Now what that allows us to do is now we use this when we talk about the x direction motion, and we use this one, which is the y, we move it for all our y equations, right? Which are these ones up here just with y direction. But what this really means is if I have a right triangle, that side's 10, and the angle is 30 degrees, that's our ramp, and I use trig, this side is 8.66 long and this is 5.0 long. Those are the exact dimensions of the sides of the triangle. So you could show you how to build a ramp. The opposite would be knowing how high and long it is, the rise and the run. It would tell us the angle. Alright? So this is going to help us when we do projectile motion problems, how we have to break it up into the x direction, and we have to break it in the y direction, and then we're going to do those separate, and that's what we're going to move into with two-dimensional problems here in a moment. So hopefully that hooked you up and got you settled with the trig needed for going two-dimensional, and so we'll see you next video when we go projectile motion.